Hello and good evening everyone. Let's continue our topic. So yesterday what we were doing is periodic table, and in periodic table we have known learned already that how to calculate the block of some element. Then apart from that we have known about the electronic configuration also. Apart from that we have got to know what is the valency. We have known already. Okay. Then we have known about group and period. How to know that which group or which period it belongs to. This is all we have to know. Okay. And here are some questions. MO42, barium 56, terbium 65, tungsten 74 and astatine 85. These are the 5 questions. For them you have to find out that which block they belongs to, then which group they belongs to, and what period they belongs to. All of these data you have to find out. Okay. Block, group and period for all of them, and for them the most necessary thing will be their electronic configuration that you have to write first. Electronic configuration that you have to write. Okay. Electronic configuration you have to write and then determine what group, what period. Good evening everyone. Yeah, good evening. Start please. Solve one by one. First solve MO42. First solve MO42. MO D block 6th group. Very good. Krypton 5D5 4D5 5S1. Okay. MO 6th group 5th period. Block also 4D5 5S1. Okay. Sixth group 5th period. Very good. 4D5 5S1. Okay. Fifth period. Very good. Okay. Krypton 4D5 5S1. 5th group 6th period. Very good. Okay. Let's see. Molybdenum 42. What is the configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d5. 4d5. See, ytterbium, zirconium, niobium, molybdenum. Okay. And this is, yeah, it will be 4s2, not 4s2, it should be, how much it is? 2 to 4, 6, 10, 10 to 12, 12 and 6, 18, 18 and 10, yeah, 18 to 30, 30 and 10, 40, oh, sorry, 20 and 20 and 30, 36 and 541 only. So it will be 4s2, 3d, 4d5. Is there some misprint? S2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Then it will be 5s1 also. Okay. 5s1 also. 5s1 also will be there. Okay. Let me write it properly. Here it will be 5s1 also. Okay. Now it is okay. 5s1 also. Yeah. Now it is okay. So what we can say, it is last electron is going in D group, D orbital, and for D orbital, what is the block number? Oh, sorry, not block number. Block is D block only, already block is D, and group number will be for D block elements S plus D, and S plus N minus 1 D, that is 5 plus 1, that is equal to sixth group D block, and which period? Period whichever is highest orbital filled, so period is fifth. That is the answer. Period is fifth. That is the answer. Till here, anybody has to ask something? Sixth group, fifth period. Okay, sixth group, fifth period. Everybody got it? Say yes or no. Write yes. Write yes in the comment box. Have you got it or not? Yes, yes, very good. Yes, very good. Yes, very good. Okay. Let us move to Ba56. Barium 56. Try barium 56. Barium 56. Find out barium 56 fast. Barium 56. Barium 56 you have to find. First write the electronic configuration, then determine block, group, period. Block, group, period. Very good. 6s2. Second group, sixth period. Very good. Second group, sixth period. Very good. Very good. Very good. Keep writing. Very good. Keep writing. Second group, sixth period. Second group, sixth period. What is the electronic configuration? What is the electronic configuration? Write the electronic configuration also. Okay. 6s2, very good, write complete. 6s2. Okay, let's move. Barium 56. Check whether this is correct or not. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, then 5s2, then 4d10, then 5p6 and 6s2. I think that is correct. 2, 2, 4, 6, 10, 12, 12, 6, 18, 18, 20, 30, 36 and 46, 48, 48, 54 and 256. Yeah, that is correct. Okay, that is correct. So what is the highest filled shell? That is sixth shell. So period will be sixth. Last electron is going into S subshell. So block will be S block. Is it okay? And apart from that, what we can say about group? In case of S block, how to determine group? The number of electrons that are in outermost S will be considered as group number. So group number is 2. So second group S block and sixth period. Second group S block and sixth period. That is the thing. Have you got it? If you got it, then please move to next. Please move to next one. That is TB65. TB65. Move to TB65. Do it fast. TB65. TB65. Third group, sixth period. Sixth period, third group. F block. Very good. Third group, sixth period. Very good. Sixth period. Very good. 10th group, sixth period. Okay, check it. Check it once. Third group, very good. sixth period. Third group, sixth period. Very good. Very good. Okay. Let's move to TB65. Check whether this configuration is correct or not. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, then 5s2, then 4d10, then 5p6, then 4f9, 6s2, then 4f9. Yeah. So I think 2, 2, 4, 6, 10, 12, 12, 6, 18, 18 and 2, 20, 20, 30, 36 and 46, 46 and 2, 48, 54, 56 and 9. Yeah, that is okay. That is correct. The configuration is correct. Okay. The configuration that is written is correct. Where is the last electron going? See, highest energy orbital is 4f. 4f9, highest energy orbital is 4f. Okay. And highest shell is 6. So block will be, because last electron is going into 4f, so block will be f block. Similar to that, highest shell which defines the period will be sixth period. And group, in term of group, all of you know that group, whenever there is a f block element, we have to always consider its group as 3. We have to always consider its group as 3. It will be third group always. It will be always considered as third group. Okay, that's it. Third group it will be considered as. That's it. Anybody has any kind of doubt, you can ask. Always third group. Tell me if there is any doubt. Xenon 6s2, 4f14. Okay. Tungsten you are writing. Okay, okay, okay. Now move and tell me about tungsten. Very good. Sanjana already written. Very good. Tungsten 74. Very good. How did 4f came? Because last electron is going to 4f. Write the configuration by your own. Actually, in this, configuration is not written according to the order of energy. It is written randomly. Okay. So you know that, for example, 4s comes here. Na? 4s is filled first. All of you know. Okay. Similar to that, 4d is filled later than 5s2. 5s2 is filled first. That kind of things. Okay. So this is the thing. W74. 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 Sixth group, sixth period. Jitendra. Sixth group, fourth period. Okay, let's see. Anybody else? Sixth group, sixth period. Apart from sixth group, fourth period. Okay, D block. Both 6 and 6. Okay, let us see. Let us see. Let us see what is there in W. W74. 2, 4, 4 and 6, 10, 12, 12 and 6, 18, 20, 30, 36, 36, 46, 46 and 248, 46 and 14, 60, 62, 62, 68 and 472 and 274. Yeah, that is correct. Okay. So last electron is going to which? See, 5d4, because d is partially filled. That means last electron is going to a d subshell or d orbital. So the block will be, block is always d block. Block is considered d block. Apart from that, if we talk about group, in case of d block group, if we have to check ns and n-1d electrons. ns and n-1d electrons, where n is 6, that is highest shell, and n-1 is 5. So 4 plus 2 will be equal to 6. Okay, sixth group. And period, obviously everybody can tell period very easily. It will be sixth period, sixth group. Sixth period, sixth group. Very good. Sixth period, sixth group. Sanjana, very good. Estatin also, very good. Very good, Nikita. Very good. Group 6. Yeah, very good. Okay. Now let us move to next one. Next one is 8085. Astatin 85. Astatin 85. Right? Astatin 85. Tell me, what is the electronic configuration? Astatin 85. Right? Astatin 17, group 6th period. What is the block? Write the block also. 17,6. Very good. Block, P block. Very good. P block. Very good. 17,6. Very good. 17,6. Very good. Okay. Let's see astatin 85. Okay. 2 to 4, 6, 10, 12, 12 and 2, 12 and 6, 18, 20, 30, 36, 46, 46 and 14, 60, 62, 68, 68, 78, 78 and 2, 80, 85. Yeah, that is correct. Okay. So outermost is going into P. That means block will be P block. Block will be P block. Apart from that, in case of P block, how to find out group? So it is very easy. That is Ns electrons plus Np electrons plus 10. Tell me, Ns electrons, that is 6s2, that means 2. Np electrons 5 plus 10, that is equal to 17. Group number is 17. That's it. Apart from that, if we talk about period, it is highest shell that is filled, and that is here you can see very easily, it is 6th period. Okay, it is 6th period. These are the questions. Till here, in any of the question, if anybody has doubt, you can ask. Anybody who has doubt, you can ask. Anybody has any kind of doubt? Sir, any easy trick? There is no easy trick. Try to know. More you will practice, more you will understand. Try not to run behind easy tricks. Tricks will usually fail you. No doubt. Very good. Please ask whoever has any doubt. No doubt. Okay. No doubt. Very good. How will came to 10 value? That is standard. That is standard. Electronic configuration of 102. You know the rule. You can write down. Following the Aufbau's principle, directly you can write. Okay. Very good. Okay, let's move. Let's move to the next topic, and the next topic that we have to do is bonding. We have to talk about bonding. Okay, what is bonding? So in bonding, the first thing that is necessary is bond, or we call it chemical bond. Okay, chemical bond is what? It is the interaction between two or more chemical species. It is the interaction between two or more chemical species. Now what can be these chemical species? These can be atoms or molecules or ions that kind of things. Okay, these are examples. Molecules or atoms or ions, that kind of things. If they are connected by some force, that force is known as bond. Okay, so what we have to know in this is there are 2-3 types of bond, or there are 2-3 theories that will explain bonding. The first one is that is known as Coastal-Lewis approach. That is very, very important. Coastal-Lewis approach. Okay, what this approach says is that every element try to fill its octet and in some cases duplet. What is the meaning of octet? Octet means that in outermost shell there should be 8 electrons. See, please be careful what I have written. In outermost shell there should be 8 electrons. Instead, other than that, some of them are there which do not go for shell, 8 electrons in their shell, but they go for duplet. That means 2 electrons in their outermost shell. And what happens to them? And means who are them? So they are hydrogen, helium usually. Okay, sometimes lithium, beryllium also work like that. But the thing is, most of the elements, 99% elements always go for completion of octet. Okay, so why everybody is following the octet, or why everybody is wanting to fill the octet, is because as soon as somebody is filling its octet, it becomes stable. What I said, if somebody is filling its octet, or if octet is filled, then it is stable. Octet is filled, then it is stable. Okay, and if you know that there are some examples of that, you know, noble gases, for example, you can say neon, atomic number 10. Okay, 1s2, 2s2 and 2p6, it has filled octet, so it is stable. Okay, or we can say that everybody wants to fill it octet, or we can say everybody wants to achieve configuration like a noble gas. Why? Because we know the noble gases that are already present are non-reactive, they are stable, they do not react with each other or any other element also. So what we say is everybody wants to be like them. Okay, so everybody wants to fill their octet or achieve the noble gas configuration. Now the question is how they will achieve. Okay, how they will achieve. So that is very easy. There are 2 things possible. Okay, some of them will have more electrons, okay, than needed, and some of them will have a little bit less electrons than needed. Okay, so either they can lose electron or gain electron. That is, in one word we can say transfer of electron. This is known as transfer of electrons. One method is transfer of electrons that we have seen in valency. Okay, in valency also we are seeing what, how many electrons are needed to be loosed or gained in order to attain noble gas configuration, that we are watching. Okay, so that is what transfer of electron. And one more thing I have given you hint about when we are discussing carbon, what I said you is one more procedure is sharing of electrons. So there are 2 methods by which any of the atom or any of the element can achieve a noble gas configuration, is either by transfer of electrons, or by sharing of electrons. Either it can transfer, either it can give, it can completely give to other, okay, or it can share. That means whenever you need, you take, whenever I need, I take. This is known as sharing. Okay, so either transfer or sharing, 2 types of things are possible, 2 kind of things are possible. Now let us think about this. Again I am drawing the same diagram. Okay, transfer, and what next thing was sharing. Okay, Now let us take an example of transfer and sharing one by one. Let us think about, there was a sodium kind of atom, okay, and there was a chlorine kind of atom, okay. What is the electronic configuration? You know, Z is equal to 11 and Z is equal to 17. Configuration is 1s2, 2s2, 2p6, 3s1. Is it okay? Similar, 1s2, 2s2, 2p6, 3s2 and 3p5. Is it okay? And 2, 2, 4, 6, 10, 2, yeah, that is okay. Now tell me, how much electrons are needed to be loosed or gained by sodium when if it has to achieve its nearest noble gas configuration, that is configuration of neon. Tell me, how many electrons are needed to be loose or gain by sodium to achieve its nearest noble gas configuration? One electron, what, lose or gain? One electron lose or gain? 1, 1 is okay. Tell me whether lose or gain. Lose, very good. 1 lose, very good. 1 lose, 1 lose, very good. See, if you see, this much is neon, this one is extra, so it will lose 1. Is it okay? So it will lose 1 electron. So I am telling lose 1 electron. And if somebody lose 1 electron, what charge will come on it? Positive charge. So it will become Na plus kind of thing. Okay, its name will be, it could be represented like Na plus, and its configuration will be 1s2, 2s2, 2p6. That is okay. Now let us move to the second one, chlorine. Tell me, what is needed for chlorine to become its nearest noble gas? To become its nearest noble gas, what chlorine should do? Accept or donate, means lose or gain. Lose or gain, 1 electron gain, lose or gain, very good. 1 gain, 1 gain, very good. 1 gain, yeah, very good. 1 gain, very good. 1 gain, yeah. So it will gain 1 electron, and it will become Cl minus, okay, and its electronic configuration will be 1s2, 2s2, 2p6, okay, 3s2, 3p6, that kind of configuration, and this is similar to argon, okay. So there is sodium that becomes stable by losing 1 electron, and there is chlorine by that becomes stable by gaining 1 electron. Tell me whether this can happen, that sodium lose 1 electron and give it to chlorine. Sodium lose 1 electron and give it to chlorine. Will both of them become stable? Because sodium needs to lose 1 and chlorine needs to gain 1. Can this kind of transfer take place? Say yes or no. Right? Say yes or no. Right, yes or no? Yes, very good. Yes, very good. Right, right. Yes, very good. Yes, it is possible. When it is possible, tell me, 1 electron is transferred from sodium to chlorine, what will happen? Sodium will become Na plus and chlorine will become Cl minus. Is it okay? Sodium will become Na plus and chlorine will become Cl minus, and you know, when they are stable and they try to go their ways, it is not possible. When they are stable like that and they try to move away from each other, it is not possible. Why? Because now they have opposite charge and opposite charges attract each other. Opposite charges attract each other. Opposite charges attract each other by a force that is known as electrostatic force of attraction. Electrostatic force of attraction. Electrostatic force of attraction. There will be a force that will be attracting each other. This will be known as electrostatic force of attraction, and that will lie between this Na plus and this Cl minus. And whenever an atom is having charge, this kind of things are known as ions. This kind of things are known as ions. A positive charged ion is known as cation, and a negative charged ion is known as anion. So what I said is, positive and negative charge, if it is there on an element, it is known as ion. It is no longer called an atom, it is called an ion. A atom with a charge is known as ion. Okay, so these two ions, due to transfer of electrons, got charge on each other, and due to this charge they are connected by this electrostatic force of attraction. This kind of attraction is known as a bond. This kind of attraction is known as a bond, and because this bond is formed between ions, that's why this kind of bond has a particular name, that is known as ionic bond. That is known as ionic bond. So I think all of you got the story of ionic bond, that how this ionic bond was formed. How this ionic bond was formed, have you got the story? If there is some doubt, you can ask. If there is some doubt, you can ask me. Ionic bond, very good. Very good. Ionic bond, very good. Why is octet configuration stable? See, till that time it was experimental, because what we have seen, those who have incomplete octet like neon and argon, these guys are stable. That's why we get to know experimentally that this octet configuration is stable. They are non-reactive, they do not react easily. Anybody has any kind of doubt? Please write specific doubts. Don't write like repeat. Don't write like this. Just tell me, repeat this part. Like this you should write. Any kind of doubt? Ionic is strong bond or weak bond? Wait for that. Okay. Any kind of doubt? No doubt? Okay. This is the story of transfer. This was the story of transfer. Okay. Now let us move to the story of sharing. The story of sharing. There are some guys like carbon. There are some guys like carbon, and these carbon kind of guys have a atomic number of 6 and electronic configuration 1s2, 2s2, 2p2. That kind of configuration, 1s2, 2s2, 2p2. Outermost shell is having 4 electrons. Now its nearest noble gases are 2 on both sides. One side helium is there, that is having 1s2, carbon is in its middle, and then on other side neon is there, that is 1s2, 2s2, 2p6. So if it has to become helium, it has to lose 4 electrons, and if it has to become neon, it has to gain 4 electrons. There are 2 ways, okay, that carbon can do, that carbon can become stable or carbon can achieve noble gas configuration, is either by losing 4 electrons or by gaining 4 electrons. But what new method it has determined, because 4 gaining and 4 losing is a hard task, it requires too much of energy, then it has found a different way, that is carbon, it is having, let us say, 4 electrons in its outermost shell. Only outermost shells are loose enough, so that can be transferred or shared. Inner side electrons are not loose enough, they are very tightly bound to the nucleus, and they cannot be either loose, either gain or shared. They cannot be loose, gain or shared, okay, only outermost electrons. What he said is, he invited hydrogens, and that too, how many hydrogens? 4 hydrogens, okay, 4 hydrogens he have invited. That also, all of them also have 1 electron, okay, they can lose or gain it, that is okay, but he called them 4 of them, and what he offered them is to share. What he offered them is to share, and they shared with each other like this. Now what is this meaning of sharing? Sharing means that he has given his electrons and his electrons both are in a combined state, both are in a together state, so that both of them have equal hold on them. Both of them have equal hold on them, like carbon and hydrogen. Later you will get to know how this hold come, and later you will also get to know some more things, but for now you can know that this is equal hold. So whenever somebody come to hydrogen, somebody come to carbon and check how many electrons you have, he said, see, 1 2 3 4 5 6 7 8. Tell me whether carbon got 8 of the electrons or not. Without losing or gaining even one electron, it has got hold of 8 electrons, and that makes it stable. That makes it stable. That is making it nearly noble gas configuration. It is also having hold of 8 electrons. Say yes or no. Is it okay? Apart from that, if any of the hydrogen is being asked that how many electrons you have, let us say this hydrogen, it is also having 2 electrons, duplet complete. This hydrogen also duplet complete, 1 2, same for this, same for this. So all hydrogens got their need satisfied, all carbon get their need satisfied, and this kind of sharing also makes a bond. This kind of sharing also makes a bond, and this bond is known as covalent bond. Covalent bond. Why? First of all, this is sharing. Co means shared, okay. Valent means valence electrons. Co means shared, cooperative. You have heard about cooperative, yes or no? So covalent means valence electrons are shared between two atoms. So two electrons when shared between two atoms, that kind of bond is known as covalent bond. So the question, I think the next question that will arise into your mind will be, can only be 2 electrons shared? Can 2 atoms can share only 2 electrons? No, there is no limit for that, okay. There is some limit, but 2 is not the limit, okay. There is some limit, but 2 is not the limit. Let me tell you different method, okay. Oxygen, atomic number 8, configuration 1s2, 2s2, 2p4. Is it okay? Outermost shell, how many electrons? 6, 1 2 3 4 5 6. Is it okay? Now this oxygen also 1 2 3 4 5 6. Let us say 2 oxygen atoms are there. Now tell me how many deficiency this oxygen has to reach up to noble gas configuration. I think 2. This also 2. So what they do is they share 2 electrons with each other. They can share 2 electrons with each other, 1 and 2. 1 and 2. 2 electrons can be shared between these 2 oxygen, okay. 2 of him and 2 of him, total will be 1 2 3 4, okay. So whenever you check this oxygen get 1 2 3 4 5 6 7 8 electrons, and same for this oxygen, 8 electrons. Both of them get 8 electrons. Apart from that, each two electrons form one covalent bond. Each 2 electrons form one covalent bond. Now tell me how many electrons are being shared between these 2 oxygen? How many electrons are being shared between these 2 oxygen? Right? Write the number. How many electrons? How many total electrons are being shared? Very good. 4 electrons are being shared. 2 of first one and 2 of second one. 4 electrons are being shared. And whenever 4 electrons are being shared, that means 2 covalent bonds are there. And whenever there are 2 covalent bonds between any 2 atoms, it is represented like this and this. This is known as a double bond. This kind of thing is known as, this kind of bond is known as double bond. This is double bond, okay. Double bond is there, okay. So this kind of bond is known as double bond. So oxygen and oxygen are forming double bond with each other, okay. I think that's it. Anybody has any kind of doubt? Anybody has any kind of doubt till here? If no doubt is there, then tell me. Okay, tell me. What will happen to these? How many electrons they need to share? Oxygen has 6 valence electrons. Carbon has 4 valence electrons, and this oxygen also 6. Tell me, how many will be shared between whom? How many will be shared? How many will be shared between which of them? How many will be shared? C double bond O, very good. CO2, 4 electrons. Hey, 4 electrons means what? Between first, write like this, oxygen number 1, oxygen number 2 and carbon. Tell me, between first oxygen and carbon, how many bonds? First oxygen and carbon, how many bonds? Sorry, how many electrons? First oxygen and carbon, 4 electrons between first oxygen and carbon, very good. And second oxygen and second oxygen and carbon, 4 electrons, so total will be 8, very good, total 8. So what they will do, 1 this bond and 1 will be this bond, 1 this bond, 1 this bond, okay, because oxygen was having a deficiency of 2. Okay, wait, let me write it on the next page. Carbon, oxygen, oxygen, 1 2 3 4 5 6, 1 2 3 4 3 4 5 6, okay, that's it. Now think, oxygen has a deficiency of 2, he requires 2 more electrons, okay, he wants someone to share 2 more. This carbon wants someone to share 4 more, okay, because 4 he has, 4 more he requires. This oxygen also requires 2 more. So this oxygen share its 2, 1 and 2, okay. This is how this has shared 2 electrons of carbon with himself. Similarly, this oxygen also has shared 1 and 2 of himself with carbon, and this is how carbon got 1 2 3 4 shared, 2 on left side, 2 on right side, and you know this is 2 electrons will form 1 covalent bond, so it will be oxygen double bond carbon double bond oxygen. That is the thing, oxygen double bond carbon double bond oxygen. This is the thing, this is the thing, okay. One more example, write about this, nitrogen and nitrogen. Tell me, nitrogen and nitrogen. Nitrogen and nitrogen. N triple bond N, very good. Triple bond, very good. Triple bond, very good. Okay, what we have to write is, see, 1 2 3 4 5, okay, 1 2 3 4 5 electrons are there. How many deficiency? 3 deficiency, 3. So it also requires sharing of 3 electrons. That is 1, then 2 and 3, okay, and this is represented as N triple bond N, okay, and 1 pair of electron will be left. Now let me tell you one more thing, there is some pairs of electron that are left, like here 2 pairs are there, here 2 pairs are there. Those pair of electrons which are left after bonding, after bond formation, whatever pairs of electrons are left are known as lone pairs. Lone pairs, that means those pair of electrons which are alone, which have no bond to form, are known as lone pairs. So this oxygen has 2 lone pairs and this oxygen also has 2 lone pairs, that kind of thing. Similar to that, this nitrogen has, I think, 1 lone pair and this nitrogen also have 1 lone pair. So these are the things, okay, lone pairs. Have you got this? Till here, if anybody has any doubt, you can ask. If there is any kind of doubt, you can ask me, okay. If there is no doubt, tell me if they have you got it or not. Tell me if you understand or not. Write in comment box. Have you understand or not? Understood? All of you understood? No doubt. Very good. Very good. Lone pairs are those pair of electrons which are left after bonding. Those which are left after bonding. See, those which cannot be shared or donated or accepted. See, in this, these two electrons are shared, but these two are not shared and these two are also not shared. So they will behave as lone pairs. That's why one pair, two pairs, two lone pairs are there. Understood? Very good. Okay. Very good. Understood? Carbon can gain electrons in this topic. Carbon can gain electrons. It is not like that carbon can never gain electrons. It can gain, but there is condition. Okay. Everything has some condition. In case of hydrogen, it will share only. Anything else? Okay. Okay. Okay everyone, that's it for today. We'll meet in the next class. Bye everyone.